Welcome to the second of the series of videos on the panels of the SMath Studio software, in which we will discuss the Matrices panel. For that purpose, we're going to use an SMath Studio file. Let's increase the size of that file 25%. And we're going to present the Matrices panel. And I just realized all the labels of the areas are in Spanish, but they are done in English inside, so we'll skip that. We're just going to open here. This is the Mattresses panel. It's the second to the right here. And it includes 11 different functions for matrices that we're going to be presenting one by one. These include matrix, determinant, matrix transpose, algebraic addition to matrix, which is also called the cofactor. A minor, the cross product of vectors, how to vectorize a function, generating ranges with a second value, and how to define vectors and matrix elements. So if you haven't taken linear algebra, or if you haven't taken any course on where we use vectors, we're going to do a little bit of definitions here to remind you. A matrix is an array of numbers with, let's say, m rows and n columns. So that's called n by n matrix. And its generic element will be referred to a sub ij, when I represents the row and j represents the column. And so for this case where we have m rows and n columns, the index I will go from 1 to, actually make a mistake here, should be m, and the j should be 1 to n. Okay? If you have a number of rows equal to the number of columns, this is called a square matrix. The function matrix control M is used to define a matrix and is the number 1 in the panel. In order to illustrate these applications, I'm going to open a new file and open the panel here and define a matrix. Let's just say define a simple matrix, a 2 by 2. I'm going to say like something like A, uppercase A, colon, click on this first matrix button, or do Control M. That produces this entry where by default you get a 3 by 3 matrix, but we want a 2 by 2, so we go here and reduce the size to 2 by 2, insert, and then we get the entries there, and we can type like 3, a right arrow, -4, for example, right arrow 2, and let's say the next one will be a 6. That's a simple matrix, right? And so in the next button here we have the determinant. The determinant of a matrix, it's a scalar. It's a single number. Let me close this. It's a single number where that defines the matrix. For example, on a 2 by 2 matrix, this is obtained by multiplying A11 times A2 positive and subtracting A12 times A21. That's the definition of the determinant for a 2 by 2 matrix. For a 3 by 3 is a little more complex, and for n by n it gets even more complex, but let's just say that the determinant function will calculate that for you. And so if I go to the example that I'm using here, and I go here and open my panels and say calculate the determinant of A equals 26. Now if you calculate 3 times 6, so we do 3 times 6 minus -4 times 2, you get that value that we were talking about. I'm going to close these, and I'm going to go back to the matrix panel. Okay, the transpose. If you have a 2 by 2 matrix, A11, A12, A21, A22. Basically, the 1-1 means first row, first column, first row, second column, second row, first column, second row, second column. The transpose simply we're going to take this row, the first one, and turn it into a column, and the second row into a second column. And basically, you exchange rows with columns. That's called the transpose of the matrix. And so, in the examples that we're developing over here, if I use these over here, you can click this before or after. Let's click now, and you have a placeholder here where you're gonna type A and say equal, and then you can see here the 3 minus 4 becomes a column now, and the 2, 6 becomes a column now. That is the transpose of the matrix. The so-called algebraic addition of cofactors, it's a function that allows you to calculate the determinant of a matrix that results from removing a row and a column, the minor ij results from removing row I and column j, and the determinant will be called the minor, and the cofactor is simply the determinant. The minor is the determinant multiplied by -1 raised to the power I plus j. What is the usefulness of minors and cofactor? This is actually to develop determinants, but this is only used when you're learning linear algebra. In reality, you're not going to use those much. And so, in order to illustrate that application, I'm going to go back to the other location here, and I'm going to drag my matrix A over here. I'm going to click on the border, and you're going to holding down the mouse, and I'm going to increase this to 4 by 4, and I'm going to put numbers in there. Arbitrary numbers there, like 6 and -7, and an 8 over here, and a -5, and then -3, and a 2, and a 0 here, and 1, and 5, and let's say a -6 over here, and a 3, and a 2. This equal sign, I don't know where it came from. We're going to remove that. Why do I want to do that? Because I want to demonstrate to you the use of the cofactors. Actually, we're going to do the determinant also. So what I'm going to do, I'm going to copy these, Control-C, Control-V. Now we have a different determinant because we have a bigger matrix, and we have a different transpose. And then I'm going to do my cofactor here. I'm going to click here, the cofactor. The name of the function is A, but it doesn't need to be confused with the A, which is the matrix from which we're going to obtain, say, the cofactor corresponding to the second row and third column. So we put 2 in the first placeholder, 3 in the second one, equal 70. That's the determinant of the matrix that results from eliminating the second row and the third column. Now, the other one is the minor, and I'm going to obtain the minor in the same position, 2, 3, and that gives me just simply -70. Why? Because -1 raised to the powers 2 plus 3 changes the sign to -1. Okay, that was the definition of the cofactor. Let's go back to the Matrices panel. Definitions for vectors. Okay, I forgot to translate that. I'm going to make sure that do that. A vector is an array of numbers of a single row or a single column. This is called a row vector, also defined in this way, or a column vector defined in this way. When we're dealing with physical vectors like velocity and position and accelerations, we only need 3 components. It is recommended in SMath Studio to treat them as column vectors. And to generate this, I use what is called a subscript. And we're going to explain those later on. You just, at this point, accept that the components of these 2 vectors are U1, U2, U3. When we deal with Cartesian coordinates where the unit vectors I, j, k correspond to the directions x, y, z, these vectors could be written this way. But in operations in SMath Studio, we want to write them this way. This way is only for reference. This is the actual way that we're going to write vectors. And so there is something called the cross product. And the cross product can be obtained using the panels with this function, cross product. And so what I did here was a click here, click on here, type U, type V, and then do control dot because it's a symbolic result to give me that result. I'm going to move it up here. And then I'm going to actually change V here. I'm sorry. The V goes right there. V cross V gives you 0. I'm going to put the U here. And what you're going to get is something similar to this, but the negative of the other one. We're going to see some examples in a minute. The way, when you use the Cartesian expression of the vectors, of 3-dimensional vectors, the cross product is actually the determinant of a matrix consisting of I, j, k, and then the components of U and V, and it produces this result. We probably learned that. You probably have learned that in your physics or mathematics. There is also called something called the dot product or the scalar product. It is simply calculated by typing U times V and then doing control dot. So basically, I'm repeating the results in here. Now let me show you some examples with actual vectors. I'm going to define a couple of vectors. In order to define a vector, you can do the math. That is a row. It's going to be a column vector, so we're going to have three rows and 1 column. And let's say we have a -2, 3, and 5. And for vector V, we're going to have, we'll do control M here. And then we have 3 rows and 1 column. And we're going to say something like 6 and right arrow, -3, -2, let's say 4. If I want to do the cross product of these 2 vectors, I click in here and then I type U and then in here V and do the equal sign. That's my cross product. If I do V cross U, click in here and do V, U equal. What you can see is the negative of U cross V. We can also do the dot product, and that will be U times V is equal to 2, which is the same as V dot U equal to 2. So those are a couple examples of vector calculations. Let's go back to the definitions here. Vectorization of functions. Basically, it means that if a function f of x represents a function you want to calculate, but your vectors, your arguments are presented in the form of a vector. I'm going to copy this. Control C. I'm going to go to the other page and actually go to the next page here. And over here, do Control V. So that's the way, and I'm going to increase this a little bit. That's the way it's going to look. So we have the function defined as f of x, sine of x plus cosine of x. And then I have a variable s with 5 values. I want to calculate the function f of x applied to this vector. How do I do that? This is how you do it. You take f of s and then selecting the entire thing, click over here, and then say equal to. What this vectorization of a function does is actually apply the function to each element in the vector and then put it back into a vector. And that could be very useful in generating tables and other applications in SMath Studio, and that's why we present it in here. I'm going to go back to the matrix panel definitions. I'm going to talk about ranges. And ranges are basically ways to define vectors with a rule of an increment by 1 or a different increment. Let me just go back to the second page that I'm working with here and talk about ranges. There are two functions in here, this one and this one. The first function, if you click in there, you're going to provide an initial value, let's say 2.3, and we want to end up at 5.1. When you say equal here, what it does, it creates a column vector that takes the first value here, increase it by 1, give you the next value, increase it by 1 again, give you the next value, and then it checks, and it goes checking that you don't go over the second value, and 4.3 starting at 2.3 with increments of 1 will be the closest value to 5.1. If I have changed this to 5.3, you get that value. Okay, so that's in increments of 1. This is very useful for ranges of integers, because if you go here and say, okay, I'm going to go from 5 to 10, type 5 here, type 10 here, and we'll go in increments of 1. That produces the vector like that. The second possibility is to have a different increment in your vector. And so if you go to this one and say we're going to start with 1.2 and we want to end in 6.7 in increments of 0.3. So what you need to do here is say, okay, well, if I do increments of 0.3, my next value should be 1.5, the second value. And when you do that, and actually here we produce a pretty big vector. We go in increments of 0.3 until reaching the values closest but smaller than the upper limit. Let's say we do integers here. Let's say that we start at 5, we go to 25, but we do it in increments of 3, so the next one will be 8, and so you have 5, 8, 11, 14, and so on. You can also do negative ranges. For example, we do a 2-position range here from the negative 10 to, let's say, negative 5 equals. When you use this function, the first value always has to be less than the second value. The same in here, the first value has to be less than the last one. But you could have a negative increase, and so you could start with, in here, say we start with 10. You want to go down to 3. And in decrements of 2, and so the next value will be 8. And so if you do that, you go 10, 8, 6, 4. And that's how ranges are worked. We're going to learn more about those, but that I wanted to illustrate those results. Let's go back to Matrices Panel. Elements of matrices and vectors. If you define a vector like this one, I'm actually going to copy this into my other page. Here's a vector, and then I'm going to also define my matrix borrowing from the other page. I'll move it to the next page. If I want to extract a particular value, I type U, or actually I could just go here and click in here and type U first, and then select the index 1, 2, 3. Let's say I select number 3, the equal sign, and it gives me 3. If you use a index like 5 that is not there, it's going to give you an error. Now, suppose that you want to redefine the second element, then you can do U. If you use the opening bracket, put a 2 in there, then use the space bar, and then use colon, and let's say we change that to -5. Okay, so we have changed only one element, but if we say U equal, then you're going to see that your vector has been modified into this one. Something similar happens with matrices. If you use A and enter the row and column, let's say the second row and third column, that'll be second row, third column is the -2, and you say equal, it gives you the number -2. And you can extract others like say A. I'm going to do square bracket, and then I'm going to do 3, 1 equal, spacebar equal. That's this one. Third row, first column. Now suppose I want to redefine one of them. I the A, click in here and say I'm going to modify the one in the middle, second row, second column, spacebar, column. It's going to be -16. If I now use A equal, I see that the 8 has been changed into -16. If I go back to the matrices panel definition, I have a place where I wanted to do some exercises, and I'm going to do it in a separate video because I don't want to make this video too long. So with this, we're going to end the video corresponding to the matrices panel.